Bismillahirrahmanirrahim. We spoke about the compound events in the last part, and we said that we have mutually exclusive events and not mutually exclusive events. Two events are said to be mutually exclusive if they cannot happen at the same time. A and B can't be happening at the same time. For example, we cannot have male and female at the same time. So male and female are two events, and these are disjointed or mutually exclusive, can't happen at the same time. If they can't happen at the same time, that will be P of A or B. If they are mutually exclusive, then the probability of getting A or B will be the sum of the probability of A plus the probability of B. If they are not mutually exclusive, it means they have something in common, then the probability of getting A or B will be B of A plus B of B minus B of A and B. Subtracting the common members or common probabilities. In this example, we are going to find the probabilities, and we see whether the events given in this question are mutually exclusive. So we can use the rule 1 or not. In that case, we will use the probability rule or additional rule 2. The gift basket store has the following pre-made gift basket containing the following combinations in stock. We have cookies, mugs, candy, coffee, and tea. And we need to choose one basket at random. Find the probability that it contains coffee or candy. I need to find P of coffee or candy. Again, when you see this preposition or, it means it is addition rule. So I'm speaking about the addition rule. So is it the addition rule 1 or the addition rule 2? We need to check. Coffee and candies are these mutually exclusive or not? It means, can we have one basket contain both of them or not? If yes, then they are not mutually exclusive. If we cannot have one basket containing both of them, then this will be mutually exclusive. Now coffee, this one, candy, see, we have intersection between these two. It means these are not mutually exclusive. Not it means that we need to apply the additional rule too. P of A plus B of B minus B of A and B. Now let's see how many coffees we have. I need to find the sum. 10 or 20 plus 13, 33 plus 10 is 53. So we have 53 coffee. We have to find the sum horizontally and vertically. T we have 12 plus 10, 22 plus 12 is 34. This is the T. Now find the sum also for each one of these. Cookies will be 32. Mugs will be 23. And candies will be 22. Now the sum for this one will be 53 plus 34 equal to 87. 87. sorry, the first one is 43. Mistaken the sum. The coffee we have 43. So the total will be, in this case, 77. Not 87, this is 77. Now I need to find the probability of getting coffee or candy. So this is equal to P of coffee plus P of candy minus P of coffee and candy, which is equal to, for the coffee we have 43. It is 43 divided by 77, the total numbers, plus P of candy. Candy we have 22. So this is 22 divided by 77 minus the common between coffee and candy, that will be 10. Coffee and candy, it is 10 divided by 77. We might have 10 baskets contain coffee and candy. So this 43 plus 22 is 65 minus 10 will be 55 over 77. So the probability of getting coffee or candy is 55 divided by 77. Now the second part, tea or candy. P of tea or cookies. Sorry, not candies. It's the same thing. Tea and cookies are not mutually exclusive. This is tea and cookies. We have 12 baskets in common. So we need to find P of t. P of t, we have 34t. So this is 34 divided by 77 plus cookies, we have 32. This is cookies. So I have 32 divided by 77 minus tea and cookies. Tea and cookies, it is the intersection between cookies and tea, which is that, and tea, that will be 12 divided by 77. 34 plus 32 is 66 minus 12 will be 54 divided by 77. So it is 54 divided by 77. This is the probability of getting tea or cookies. So this is the idea. If we have two events which are not mutually exclusive, then we have to add the probability of the first event and the second one minus the common between these two. Let's take this example. The frequency distribution shows the number of medical tests conducted on 30 randomly selected emergency room patients. Number of tests, if it is 0, we have 11 patients with no test done, 9 with 1 test, 5 with 2 tests, 4 patients, 3 tests, and 1, 4 or more tests. If a patient is selected at random, find the following probabilities. The patient has exactly 3 tests done, exactly 3. So B of exactly. This is exactly 3. How many patients we have? We have 4. So it is 4 out of 30, because we have 30 patients. When we say exactly, it means we are just taking that number as it is. No need to add something up or down. Because in the second part, the patient has at most 2 tests done. At most means less than or equal to 2. This is the meaning at most. At most 2, it means 2 or less than 2. 2, 1 or 0. So P of at most so it is this one plus the 2 above the 2 also. So it means I have to add these numbers, not these. It means the number of patients. How many patients in this criterion who got at most 2? It means 2 or less. So it means we need to add 0. Number of patients got 0 test. Number of patients got only one test, and number of patients got 2 tests. So when we see this at most means less than or equal to 2 tests. Less than or equal. It means 2 or less. So this will be 11 plus 9 plus 5 divided by 30. That will be 25 divided by 30. Or it is 5 over 6. So at most 2, it means 2 or less. So I have to add all the numbers above that 1, including the number 2, or the number of patients got 2 tests. The patient has 1 or 2 tests done. 1 or 2. So B of 1 or 2. This is B of 1 plus B of 2. Because this will be mutually exclusive in this case. And or means addition rule. Number of patients got only 1 test. They are 9 and 2 is 5. So this is 9 over 30 plus 5 over 30, which is equal to 14 over 30, or 7 over 15. 7 over 15. Last one. The patient has fewer than 3 tests done. Fewer than 3 tests done. This is less than 3. Less than 3. It means, okay, P of getting less than 3. It means B of 0 or 1 or 2. This is similar to that one, less than or equal to 2. So it is 0 or 1 or 2. When we say less than 3, it means you got 0 or got 1 test or got 2 tests, and this is equal to 11 plus 9, because 9 got 1 test, plus 5 got 2 tests, divided by 30. We found it before, it is equal to 25. So it is 25 divided by 30. So the probability of getting a patient that has fewer than 3 tests done is equal to 25 divided by 30. So this is the idea of finding a probability or addition rule. For the probability, if we have OR, we add the probabilities of the events. If they are mutually exclusive, then it is P of A plus P of B. If they are not, then we have to subtract P of A and B.